All right, all right. So, ladies and gentlemen, we got a test coming up again, either Tuesday or Wednesday for you guys, and I'm going to go through your formulas, chapter by chapter. Try to do it quick for you, and then hopefully we get out of here. So here we go. I got chapter 1.1. The first question that you are going to see on the test is distance. We should know how to find the distance between 2 points. So I have d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay. Again, this is essentially, and I can zoom in a touch more here. This is essentially distance formula is essentially Pythagoras. Think of this as c. If I square both sides, it would be c squared equals a squared plus b squared. All right. So that's how they derived that. We talked about that in class. So again, that is distance formula. Every time we do this test, the first question is always distance formula, and I will get answers that are like 2/3 and -7/5 and yada yada. And that's the people that don't read and they go right to slope and they put the slope formula down. So be very careful. I'll try to remind you while you're taking this test. The first question is in order on how we learn this stuff, and that would be all the way back to distance formula. First question on there is distance formula. And then the second question, we talked about midpoint. Middle. I'm looking for the middle of 2 points, right? It's like finding the middle of 2 scores. That's average, okay? So if I want to find the average of something, I add them up and I divide by how many things there are. And if there's only 2 points, I divide by 2. So if I want to find the midpoint of the x's, I add my 2 x values up and I divide by 2. And if I want to find the y value for the midpoint, I add my y's up and divide by 2. So y'all, that's what we did in chapter 1.1. We talked about distance and midpoint. From there, we talked about chapter 1.2. And we talked about x and y intercepts. We talked about x-intercept. We talked about y-intercept. Okay? So we had something like this. We had 2x plus 4y equals 8. We had a line. This is standard form, right? So we had a line and we said we'll find the x and y intercepts. Well, we can do that pretty easily if we remember that an x-intercept is when y is 0. So we plug that in. Use the cover-up method. So I plug in 0, and it leaves me with 2x equals 8. And we divide by 2, and I get x equals 4. Now, my math lab, when you take this test, it's either going to be multiple choice or you got to put this in as an ordered pair. So again, that'd be 4, 0. Vice versa, the y-intercept is when x equals 0. So I cover that up, I plug it in, I get 4y equals 8. We divide by 4, and we get y is 2. Make sure you write that as an ordered pair, and that's 0, 2 for the x and y intercepts. How's that, ladies and gentlemen? Do we have any questions? So far, so good. All right, then we talked about symmetry in this section. We took an equation like this, y squared equals x, and we wanted to know if that thing was symmetric to the x-axis. Well, some of you guys would try to put this in your calculator. The problem with that is your calculator doesn't have a y squared equals, it's y equals. So that is an issue. So what we did in class, we showed you how to do it algebraically. We took a point, let's say we took the point 2, 2, and then we flipped it over the x-axis. Well, that point is now 2, -2. And you can see that the y values are changing. The y's are going to negative y. So what we did is we rewrote that equation, but instead of y, we put a negative y and we simplify. So we took negative y and we squared it. Negative times a negative, or a negative squared, is now a positive. And then we compared this to where we started. Well, this and this are the same now. So if it's the same, then the answer is yes. This is symmetric to the x-axis. Well, then we took that same point and we flipped it over the y-axis. So 2, 2, and we flipped it over the y-axis. Well, now it's negative 2, 2. So if we're checking for symmetry over the y-axis, we said, well, take the x and replace it with a negative x, because now that 2 is now a negative for the x value. So we rewrote the equation, so it's y equals x, but instead of x, we put in negative x. Now there's nothing for us to simplify there. It is what it is. It's y squared equals negative x. Then we compare it to where we started, and that is clearly not the same. So not the same is a no. There's no symmetry over the y-axis. And then last but not least, we did over the origin. We took 2, 2 and we flipped it over the origin, and now it's negative 2, negative 2, and you can see that both values have changed. So if we're going over the origin, and let me know if I'm going too fast, both change. We replace x with a negative x, and we replace y with a negative y, and we see what we get. So we have y squared equals x, and I'm putting in negative y and a negative x here. Well, when I take a negative and I square it, I get back that positive, but that's equal to negative x. That negative x doesn't simplify at all. So that's not the same. So that's a no. Okay. So what does the graph y equals x look like? Well, eventually in the next few chapters, we're going to investigate that guy, and it's going to be a parabola on its side. Now the problem with your graphing calculator does not graph a graph like this, because this is not a function, and that's what we're going to talk about in the next chapter, chapter 2. What are functions, what are not functions? And for every x, it can only have one y, which means it can only be a function if it passes the vertical line test. Okay? So this one you cannot just graph in your calculator unless you know the trick. The trick is, if I was to square root this thing, I would get y equals plus or minus the square root of x. Well, that means I could graph y1 as the positive square root of x, and then y2 would have to be the opposite of the square root of x. So you'll graph the first part is this, and negative square root of x would be this part, and then you would be able to see that it is symmetric. But if you don't know that trick, then you would not be able to graph it on the calculator. Yes, sir.
So on a test, is it going to ask just to find symmetry? It's not going to ask us to solve it?
It's going to ask you what is it symmetric to, and you are either going to have to use algebra to do that, or if you can, look at the calculator. If you're able to plug it in. Okay, does that make sense? All right, questions with chapter 1, 2 stuff. All right, we're going to dive into chapter 1, 3. Let me get another piece of paper here. And this is where you probably want to get your calculators out. So in chapter 1, 3, we talked about solving an equation like this, x cubed minus 4x plus 2 equals 0, to find what we call the roots, to find basically the x-intercepts or the zeros of this function. Okay, so what we did is we said, well, this is going to be our y1, and then this is our y2. So we put that in our calculator. So if you want to get your calculator out, you can do that real quick. So I'll walk you through. Again, we go to y equals. I type in x raised to is above the division sign 3. And then use your directional pad to get out of that if you have an 84. Minus, use the minus sign above the addition sign. So anytime you're doing a plus or minus terms, it's always the ones on the far right you use. So then it's 4x and then plus 2. Second thing, I want to have y2 is 0. Okay, got to have both of those equations. So one side is y1, one side is y2. And I want to know where they're equal. And it's going to say that the graph is going to be between x values of -10 and 10, which means zoom 6 is going to be perfect. So I press zoom, and I can either toggle down to 6 or press the number 6, and I should be able to get that graph. Graph it. So zoom 6, zoom standard. So this is where you're like, Mr. Gotch, I'm getting an error message. Mr. Gotch, I'm having problems. Mr. Gotch, I don't see that. Help me out. Is it?
Could you repeat through after clicking y equals? Because I kind of got lost after that.
Do you have this punched in?
Kind of blurry for me in order to see it.
You have that now?
So it's y equals and then punch in
X cubed. X cubed minus 4x plus 2, and then y2 is 0. And then we do zoom 6. So you can see I've got the blue function is x cubed minus 4x plus 2, and then y2 is 0. You can see mine's red, hopefully. Any issues there, y'all? So now, in chapter 1.2 and 1.3, they ask you for the same thing. They want you to find the roots, and roots are the same thing as zeros, which is the same thing as x-intercepts. We should be able to find x-intercepts on our calculator. So second trace, we go down to intersection. Number 5, either press 5 or go down to number 5. Okay? So this is where it says first curve, second curve, guess. So we press first curve, enter, second curve, enter, and guess. This is where I move the little marker over, okay? Mario, Luigi, whatever you want to call them, okay? I have 3 zeros or x-intercepts that I want to find. Well, I'm going to move all the way to the left. I can even move way over here. And anytime I press enter, it's going to find the nearest one. So I press enter, it's going to jump to the farthest one on the left. I got -2.21. You should not write anything until you see the word intersection. So I get x equals -2.21. Anybody having issues with that? Well, I still have 2 more to do, so I have 2 more second trace intersections to do. So I go second trace, intersect, number 5. First curve, enter, second curve, enter, guess. I move it over towards the middle one. Again, it finds the nearest intersection. And the middle one I got was positive 0.539. So if I round that, that's just 0.54. All right, so I found the one on the left, I found the one on the middle. Now we got to find the one on the right. So I do it again in second trace, intersect, first curve, enter, second curve, enter, guess. This is where I move it over, and you have to press enter one last time. Okay, so if I move it over one last time, press enter, I should see the word intersection, and I got 1.675 and that's 1.68 if I round to 2 decimal places. Okay. If you're giving the answer and it says guess, you're wrong. Okay. If you're using just trace and you're moving around like this, guys, that is not very accurate. You're close to it, but it's not going to get it exactly right. You're going to be pretty close, but you're not listening. You got to hit second trace and use the calculate menu. It will find the actual intersection. Okay, so just don't press trace and move around and hope you get it, because that's not how it works. Okay. All right, guys, have any questions with finding x-intercepts with your calculator? Chapter 1-2 talked about y-intercepts, so I'm going to hit that right now. So that's where you go second trace value. Number 1 is value, and we remember that y-intercepts are when x equals 0. So you press 0 and you get 2. Okay. So I just went over how to find x and y intercepts with your calculator. Second trace, intersect, and second trace value, x equals 0, press enter, jumps to that y-intercept. Or, it's really easy just to use the cover-up method, right? Cover up the x's, you're left with the constant of 2 at the end. All right, do you guys have any questions with that? So again, kind of walking you through what we've done. All right, so chapter 1-3, then I am going to dive into some of the appendix stuff just so we have it talked about. We talked in chapter A6 how to solve quadratics, how to solve something that looks like this, ax plus bx, ax squared plus bx plus c equals 0. And we talked about there's lots of different ways to solve a quadratic. We could factor, we could complete the square, okay? These are all things that we've been working on. Or you could use the quadratic formula. You're probably not going to need the quadratic formula, but just in case, if you forget how to factor, this is another option. Are you ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice that division sign goes all the way over to the little negative b. Okay? You divide the 2a last. Okay, so if you ever have to use quadratic formula, the division of 2a is always the last thing you do. Take care of the top first. Simplify the top before you do the bottom. Then we were moving on to A10. So in section A10, we talked about absolute value inequalities. If I had like the absolute value of 2x minus 1 equals 9er, just basic absolute value equation, we should be able to solve something like this. Okay, we always isolate the absolute value first. Okay, so we'd add the 1 over. We would get the absolute value of 2x is equal to 10. And now we break it up. This would be 2x equals 10 or 2x equals negative 10. There's 2 answers here, one a plus, one a minus. We divide by 2, divide by 2, divide by 2, and we get x equals plus or minus 5 for your solution set. Okay. Also in this section, we talked about square roots. So you might have saw something like this, the square root of 2x plus 3 equals 5. Okay, so you should be able to solve something like that. We also talked about, I can even give you a harder one from this section. We also talked about how to solve a square root that looks like this. Making this up, here's x on this side. So again, this is from A10 and A6, and we covered those 2 sections together. This was, let's say, negative 10 and a negative 7x, like that. So we talked about anytime I have a Square root, we always want to isolate the square root so that we're ready to square both sides. And this drops off. And now I have a quadratic equation. Anytime I have quadratics, probably the easiest way to solve these things is to get your stuff equal to 0 and try to factor it. We get 0 equals x squared plus 7x and then plus 10. Okay, don't worry about that part. So quadratic, look to factor, factors the 10 that add up to 7, or what, x plus 5 and x plus 2, something like that. And then potential solutions. If I set each one of those equals 0, remember, you get opposite of what you see in parentheses. So if I set x plus 5 equal to 0, I would subtract it over and I would get negative 5 as a solution. Same thing with the 2. I would get a negative 2 there. Okay? Now, if you type those into my math lab, you're going to get both of these wrong. Both of these, okay, you need to check it. I always say the square root kind of looks like a check mark, so don't forget to check these. Anytime you get a square root equal a negative number, it is a no solution. Okay? So if I go and put negative 5 into here and then into there, I would get a square root equals negative 5. That's not going to work. That's what's called an extraneous solution. Same thing, if I plug in negative 2 here and here, I'll get a square root equal negative 2. That ain't going to work either. So we did all that work for no solution. So double check. Just because you think that's the answer doesn't mean it's the answer. You got to double check those. All right, a couple more sections left, guys. I'm almost done here, working way through. Then we did A9 stuff. 8.9 is, again, something that looks like this. Maybe we have 4 is less than 2x, which is less than or equal to 10. We should know that this is an and inequality. Okay, so we talk about solving compound inequalities. If you have one like this, think of 3 columns. If you divide by 2 over here, you got to do it to over here. So you divide everything by 2. And we get 2 is less than x, which is less than or equal to 5. So that looks like this on a number line. This is 2, this is 5, this is a parenthesis, this one would be a bracket shaded in between. Interval notation would look something like this, 2 comma 5 bracket. So far, so good. We also talked in the second part of A9, we talked about absolute value inequality. So if I had the absolute value of x, just do an easy one, is greater than or equal to 9, then we need to know if that's an and or an or. So we talked about, we'll rewrite it. X will be greater than or equal to 9. And if it's greater than or equal to, it's an or. And the little trick was greater than. So the x and 9 stay the same, but now we multiply this guy by a negative. And anytime you multiply by a negative, we need to flip our sign. So now that's greater than. So we graph that one. Here's negative 9. Oh, that's less than, sorry. So flip that sign also. So multiply this one by a negative, this becomes less than. Sorry about that. Paying attention. So x is greater than or equal to 9. That's a bracket on 9 going to the right. And x is less than or equal to negative 9. That's a bracket to the left. So working left to right, as I see, this goes and goes and goes and never stops. It goes all the way to negative infinity to negative 9 bracket. Union or 9, and it goes all the way to infinity. So that would be your interval notation there. So that was your A9 stuff that we talked about. Some inequalities that you should know. I hope this is helping out with y'all. Last but not least, we finished up with chapter 1.4 and 1.5. So I'll give you those formulas lightning fast. Okay. Stop me if I'm going too fast. So chapter 1.4 is where we talked about lines. And when we talked about lines, the first one we talked about was slope. So we talked about having your X's on the bottom so your picnic table stays up. And then we had our margarita glasses. You got to be 21 to drink. And this is subtraction. So y2 minus y1 all over x2 minus x1. So that's our slope formula. Once we have slope, then we can do point slope. And if we got point slope, that was just y minus y1 equals m times the quantity minus x1. And then once we have that, we can distribute and add or subtract over, and then we can get our slope intercept form. And it should look like this, y equals mx plus b. And the questions that I selected for the test give you the option to either use general form, which is standard form, or you can use slope intercept form. Okay, and I think everybody knows how to get into slope intercept form. Also in this section, we talked about parallel lines. And then we talked about perpendicular lines. What do you guys know about parallel and perpendicular lines? Parallel lines. What do you guys know? We know nothing. Oh man, we're in big trouble. What do you guys know about parallel lines? Sydney, Jose, Caitlin, Duncan, what do you guys know about parallel lines? What do you guys know about perpendicular lines?
For parallel lines, the slope stays the same. And for perpendicular, the slope flips.
The old flip and switch, right? Fantastic. So if I have a slope here that is 2/3 for these blue lines, then the slope that's parallel to that stays the same at 2/3. And we talked about this in the warm-up today. This guy's slope is flipped and switched to a negative. So 2/3 is now -3/2. Okay, so don't forget to switch the sign to negative. One's going up to the right, one's going down to the right. So one's a plus and one's a minus. Very good. Last but not least, ladies and gentlemen, and this is where we finish up with our formulas. Woo! We talked about a circle. Standard form of a circle is x minus h, quantity squared, plus y minus k, quantity squared, and that equals r squared. Okay? Your center is always opposite of what you see in parentheses. And then r is for your radius. Remember that number is going to be between 1 and 10 most likely. It's not going to be very big. So make sure you square root that number at the end. Okay? So ladies and gentlemen, that is basically everything we learned in the last 3 weeks. I'm going to shut off this recording here.